that everybody's happy so far. See the difference. Some leaves are left as empty. That's absolutely fine. Other leaves contains some of the data, no more than 1 point, obviously, at least not permanently. Let's think about another scenario. Both A and B, large enough, both A and B fall in the same quadrant, so the root had to be split. This quadrant takes no points during the split of the root, and the northwest quadrant temporarily store A and B, and now it says, oh, I need to split as well. Creating my 4 children, and and repeat the same process recursively. A and B are both stored right here. Each one of my children will check A and B and ask, should I store them or not? Right. So that's the example that you see on the slides in the top right quadrant, the northeast. You see the points A, B, and C. You see the points C, E, and B. Let's tell you what is this quadrant. By the way, let's talk about the indices of the quadrants. I looked at the northwest quadrant was named 0, 1, 2, 3. That's the northwest. And once I split it, and for example, this quadrant was named quadrant 0, followed by quadrant 3. So if you look at the numbers that appears on the quadrants, quadrant 1, 1, quadrant 1, 2, 3, and so on. That's not 123, it's quadrant 1, followed by quadrant 2, followed by sub-quadrant 3. Okay? Why is it convenient to keep this naming of 0, 1, 2, 3? Is because when you look at the structure of a node, of the quadtree, it will be an array that has 4 items, and you keep an agreement with yourself that the first pointer, the first reference, would be to quadrant 0, second one would be quadrant 1, 2, and 3, and so on. So you don't need to store any other information in the node. You just keep an agreement with yourself about these quadrants. So that would be, that's how we stored a set of points. What would be the height of the quadtree in the worst case? That's not on the slide. It takes a bit thinking. If the points are real number, if all the points are real number, can somebody tell me what would be the maximum height of the quadtree? It takes a bit thinking. That's if they have integer coordinates and they are on the region between 0 and 1. So if you're storing them to store points that they all have integer coordinate, then we start at 0, 1, ... 2 to the age. So of course, age will be the bound on the height. That's why. What if they have real coordinates? You're using floating points. Can you look at the set S? S that contains A, B, C until Pn, the last. These are my data points. Can you look at this set and tell me what would be the height of the quadtree? Slightly tricky. And to make everything simple, let's assume that everything here is that my coordinates are all numbers, the x and y's between 0 and 1. So maximum number is 0, minimum number is 0, maximum is 1. Let's make it a bit easier. What happened if I only have 2 points? What would be the maximum height? In every well-behaved tree, yes. In Quadtree, no. If I have 2 points, how it's possible that if I have 2 points, that was my original drawing, one was here, far, far away from each other, and the moment that I created my first split, they were in 2 different quadrants. Can you now increase the height somehow? So first, how do I arrange my data? If I want to create a quadtree as high as possible, where should my 2 data points be? Then it's a minimum height. Then the moment that I split, here are my 2 data points, then my first split puts them on two different children, and we are done. If here is A, here is B, no need to split any further. That's for the minimum height. I'm asking for if I want to increase the height. I'll play it simple. Only 2 points. Excellent. Here is one. Here is another one. So both A and B are very close to each other. Doesn't need to be, if they are in the corner or not doesn't matter very much, but what happens when they are very close? I try to separate them. Actually, the corner is a good, I stand corrected. Corner is a good choice for one of them. Second data point is as close as possible. 2 data points. Let's roll them again. Here are my 2 data points. Very close to each other. And what will be the structure of the quadtree right here? If my whole data is just these 2 points over here. The root looks at all the data. It sees both points, call them A and B. And in one of the quadrants, it says, I store more than 1 point, so I need to split. 3 of the children are empty, stores nothing, and 1 child stores both A and B, both points over here, so this guy has to split. But I still did not separate them. So this child will have to split again. And so on. And until I am in very low resolution and finally able to separate them, I'm not happy that they are in different quadrants. And that's fine. That's a property of the quadtree. It has variants that don't suffer so much from it, but yeah, you see only 2 points, and the height, if they are all integer coordinates, somebody already said it, but please say it again. If the numbers are all integers between 0 and 2 to the age minus 1, what would be the maximum height, even for just 2 points, very small data? How high will be the quadtree? And about grading, I'm not doing anything bad to students that don't participate in the class discussion in the meetings or the piazza discussion. There is no penalty against not participate, but if you do participate, it's obviously something that I try to remember. And if you participate, like actively participate, you're making noises, you're throwing ideas, I don't care, correct, incorrect, you're making yourself noticeable, and you happen to have a grade that is, say, you got 88, 89 in your final grade, which I can understand as both B or A. If you did participate and seems to be active, you are much more likely to fall into the A category. Well, if you've never said anything, then all I know about you is your numerical grade. So there is scenarios that it will influence your final grade. If, in other words, try to participate. Yeah, and people are saying correctly, yes, that after age many steps, I have to separate them because they have integer coordinates. If they don't have integer coordinates and people store scientific data with float coordinates all the time, astronomical data, for example, partitioning of the sky into quadrants, but in this case, the parameter that really matters is the minimum distance versus the max distance. The ratio between the minimum distance, between the maximum distance between any 2 points versus the minimum distance between any 2 points. Look at this ratio, look at log to the base 2 of the ratio between the maximum distance between any 2 points versus the minimum distance between any 2 points. That will tell you what the maximum height of the quadtree. Okay, so that's the drawback of the quadtree unless you're doing something about it. Let's ask, how do I do point location? Point location meaning I gave you a point location query, meaning I gave you a query point Q equals some value x and y, and I'm asking either any data point that falls on that Q just landed on some data point. Sure. By the way, it's alone. There is a wonderful story that one of our faculty, and it's apparently a true story, that one of our faculty was at the hospital with something, was a few days hospitalized. And the nurse came, and apparently a true story, the nurse came to his bed, and there is a chart next to the bed, and the chart says Professor John Smith. And she asked him, Professor, to what are you? And he said, computer science. And she said, aha. And erased the professor word before that because it's not a real professor. The hospital, you're not really getting the VIP treatment that a real professor are getting. So here is my data, A, B, C, for example, which will give me the quadtree or the quadtrees that you see in the slides. And given a query Q, which is X, Y, is Q, I just needed answer yes or no, is in the data set. That is the input set of points that the quadtree stored, A, B, and C. I tell you, Q, I just teleported, I jumped in Minecraft from one location to another. I just landed right here. Are you on one of the data points or not? And of course, I can ask, hey, the coordinates of Q, does it equal to the coordinates of A? Does it equal to the coordinate of B equal to the coordinate of C? But if I have a lot of points, that's a much slower operation. Again, the input is not the data points only, the input is the quadtree that I already built. The input would be the quadtree that I already built for the points A, B, and C that stores these points, like you see in the slides. You see that some of the leaves stores a data point, and other leaves are empty in the trees that you see in the slide. Let's go back to the case that a quadtree stores an image. Quadtree here stores an image. Every leaf is either fully red or fully green. And I gave you, once again, a query point Q. A query meaning it's not part of the data. I just told you about a query point, and I'm asking, hey, this query point Q, is it a green pixel or is this a red pixel? How are we using the quadtree that you see in the image right now? You're given the quadtree, how can you use it to find if Q is green or red? Exactly. I'm going to the root of the quadtree, and I ask the root, hey root, are you a leaf? And if you're a leaf, then you have a color. You're either fully green or fully red. The root would say, I'm not a leaf. Actually, I have 4 children that I belong to, meaning I am gray. If gray is a combination between red and green. Oh, I'm somewhere between. I have children that are both red and children that are green. So the root cannot say if Q is green or red. What are our next steps? Check each one of the 4 children and figure out that which one of them contains Q. And we'll go back to how do I check which one of these children contains Q. There is a very quick and elegant way to check which of them, but to start with, you know for every child what is the region that is associated with. And you are allowed in the homework, in the implementation, to have every node V stores exactly what is its region, say what's the lower left corner and the upper right corner of the region. Practically it's not necessarily, but you can easily find this path, but it's okay to store it with the leaf for debugging purposes for sure. Okay, So what do I do with Q? It says the root was a leaf. I'll have to go to one of the quadrants, this one of the children that contains Q based on X and Y. One of them contains Q. If it's empty, then of course Q doesn't land on any data point. If it's not, in the case of an image, if it's a leaf, then it has a color associated with it and you're returning this color. Otherwise, you're returning, you're continue recursively until you reach a leaf. Back to the case of data points, and you see that, that we already had the answer in the chat. Based on the data points, I'm going to the root with Q. I'm asking is Q lies on any of the data points. The root doesn't store any, the root is an internal node. It has children. Go to the correct child that contains Q and check if the data points, now in my quad tree, let's write the quad tree in a more precise way, or let's refer to the slides. Let's say if Q lies in quadrant 2, then I branch from the root to quadrant 2 and realize that quadrant 2 is empty, so Q doesn't lie on any data point. If Q lies in quadrant 3, then I go to quadrant 3 that contains a point D, quadrant 3 that contains in the slide the point. Here is D, here is Q, and now I need to check explicitly D. All I know that this quadrant 3, contains D data point, but I don't, without looking at the data, I don't know what the coordinates of D. So now I need to check, but it's an efficient check because a quadrant will contain at most one point, so it's very quickly to perform the check once I reached a leaf. Does it actually lies on the single data point that lies there? In the homework implementation, you'll have 3 segments per leaf, at most 3 segments per leaf. So point location will occurs in, you'll have to check at most 3 segments. What was the time for performing the query? It will be the maximum. It will be the height of the tree, because at every level, when you're walking your way downward, at every level you will spend a constant time. So the time equals order of h, the height, but possibly it will be much less than age. It's not a tight upper bound because maybe I stopped my search at this node or nodes that are much closer to the leaf. So in practice it works very well, despite being somehow less than optimal in general. Age is usually quite small, but even if age is high, you have a good chance that you'll stop the search much faster. So, well, it's depending how the data set is distributed. If you look at the tree that you see on the slide right now, if I find A, I only have to go down 1 level from the root, because A is in level 1, while if I'm searching for E, it will take much more time. Makes sense? Because I have to go all the way from the root to the most remote leaf that is no more than age, but is actually age. So now, what happens if and this operation you have to implement, and so please concentrate. So how can I find all the points, or in the homework, all the segments that are relevant to a query region? And let's talk a bit about this big difference between query versus the dataset. the idea about the query, the idea is that I gave you the input segments or input points, and maybe you'll have a lot of time to meditate for them, put them in the data structure nicely. And now I'm going to make a decision of I start playing my video game. I start playing. I want to decide where to place a wall mount in different scenario, and I'm going to check a lot of queries. I'm going to try and try again and try again a lot of queries, and I need for every query, every guess, every step of the video games to have a prompt reaction. I want to answer the query as fast as possible, because even though I'm talking about one query, always think in mind that it's a rush time, and there is not only a single query, but it's a long stream of queries that is arriving, and you need to do something with each one of them. So now my query will be a disk. In the homework, in the implementation, the query will be a rectangle, axis parallel rectangle, but visually to make clear what is what, I'll use queries that is a disk. So the query here is a disk, for example. I think about I just teleported to this point P, this point small q, and I want to know which other players I have at radius of 5 miles away from me in my computer game. For example, this might be an application, and I now want an answer that will be as quick as possible. And that brings us to the report procedure pseudocode that you are implementing, which will say the following. I'm looking at a point at the query region disk or rectangle Q, and I'm looking at a node V, and always I'll have with V, don't forget, for every node V, and node of the tree might be a leaf, might be internal node, and there is always a region R of V that is associated with V. What is a region of V? And now we're going through the end. As we said, the goal is to report all the points which are inside the query region, query disk or query rectangle. It's much easier to implement with rectangle. We'll talk about it. Much easier to implement with rectangle, but it's not hard to do it with a disk, and the principle is absolutely the same. So, what are we checking? If V happens to be empty, you landed on a null. If V happens to be null pointer, you landed into an actually empty node. Then obviously this empty node of the tree doesn't contain any data points, so you're returning null. Then just return, do absolutely nothing. Next, if V is this joint from Q. Oh, sorry, if R of V is disjoint from Q. Now I don't care if V is a leaf or not. There is always a region R of V. I know what is, say, the lower left corner and the upper right corner of the node associated with V. The same goes with inner one. And now I'm asking, are they disjoint? Disjoint, well, graphically, means here is disjoint, means here is that here is Q, somewhere here. Here is R of V, and they have no point in common. Not necessarily data points, no points at all. They are far away from each other. No, they don't share any geographic. location, and then of course R of V, or the subtree of V, has all the points that R of V might contain, all the points that R of V, all the data points that it contains. 9 of them are inside the query region. So again, your second condition is also return null. Don't continue to the recursion. Now, how do I check if they are disjoint? You can do it. It's not too hard to do it when it's a disk, but it's even easier when the query region is an axis parallel rectangle. Right? Here is Q. You know what is a minimum x, a minimum y. Minimum x, minimum y. You know what is a minimum x, minimum y over here. And if the maximum x, the rightmost point of Q, is to the left of the minimum, the leftmost point of R of V, they are separate from each other. They are disjoint. So you're saying they are disjoint. Similarly for the y direction. If the y values don't overlap, they are disjoint. Okay, that brings us to condition 2. Now, if R of V is fully contained inside Q, you have it in the slides, but let's draw it. Here is Q, big disk or big rectangle, and here is the region, the quadrant R of V. R of V is a node of the tree, so its region is one of the quadrants. R of V is fully inside Q. Then obviously every point inside that is in the subtree. If I look at the subtree of V, every data point that is there is also inside Q. So you can, at this point, you can just report all the points in the subtree. I mean, maybe Q contains other data points from other pieces of the tree, but all the points in R of V, since the region of the quadrant is definitely inside the query disk, then every data point is also inside the query disk. So I'll just automatically spit out all of them if I need to print all the players that are 5 miles away from me. Definitely every such point is such a player, and I need to take advantage of it. Next condition. And again, similar thing you'll do for the segments in the homework. Next condition here is, oh, by the way, before that, if the query, as in the homework, if the query is actually, if Q is a rectangle and R of V is a square, and actually R of V, how do I know that R of V is fully inside Q? Very easy to check. The minimum x of the query, will be smaller than the minimum x of R of V, and the maximum x will be larger than the maximum x of R of V, and similarly for the y. 4 conditions to check, but every condition is just to check 2 numbers, is this larger than this. And the way that queries will be given in the homework would be either you'll read a query from the line, and it will start by the letter report, and then will come x1, y1, x2, y2. x1, y1 would be the coordinates of the lower left corner, and x2, y2 would be the upper right corner. So it's very easy to check if R of V is inside Q. You'll also have an operation called count in the homework that asks how many points do I have inside the query region, and when you're getting to this condition that R of V is fully inside Q, then you just need to know how many points R of V, how many data points ROV stores. In the homework, it will be endpoints of segments that ROV stores. And you're saying, I don't need to know about each one to know the identity or the location of each one. I'm sure that they are all inside Q. So I'll take the number 5 and add it to my answer. But for this, every node V will have to store some counter that is associated with it. Will say in my subtree of V, I store 5 data points. So if you just want to report their numbers, these are the points that you're talking about. When I'm talking about data points in the context of the homework, it will be sometimes the endpoints of the segment. The operation count is limited to endpoints of segments. I don't care how many segments there are inside V. I'll ask the operation count tries to ask about how many endpoints of segments there are. Don't care about the segments themselves. Continuing with the different cases of the report. The next case of the report is that V is a leaf. V is a leaf. And if V is a leaf, then there is possibly no data point inside it, possibly one data point inside it. And you are given Q, the query region. We said that red is a query. Here is Q, here is V, which is a leaf, ROV, and V is a leaf. There is a data point, and now I'm checking, is this data point inside the disk? Is this data point outside the disk? I cannot know, since it's not true that the whole region is inside the query region, otherwise I would catch it earlier. I don't know that the whole region is inside. Then they must overlap, and does the overlap contain the data point or not? I don't know. I have to check exactly what the coordinates of each one and answer accordingly. So in this case, you have to check each of the points that are stored in ROV if they are inside Q or not, and report if yes, or count if yes. Finally, in condition 5, what case 5 means? ROV partially overlap Q. In this case, I start, possibly this is Q, one big disk. It overlaps the root, but it doesn't contain the region of the root. So what should I do? As a node V, I say I have no clue, and I'm not going to make any smart decision about the condition B of my children versus Q. It's not my responsibility to decide which of my children is relevant to the query or not. It's a children's responsibility. All I do is call recursively, that's what you see in condition 5. ROV partially overlaps Q, some points inside, some points outside. So I'll just call the operation report recursively. Report on the northwest, report on the northeast, report on the southwest, southeast. Okay, just call it recursively and then let each child make the decision recursively. You can prove some bounds about it. Possibly it takes a lot of time to answer such a query, but it's probably much, much faster than exhaustive search, and it's usually very efficient because why? If your query region talks about the East Coast, you are very quickly in the tree discover that it has nothing to do with the West Coast, so you only filter out into regions in the East Coast and so on. It's a very efficient way to filter, to avoid visiting huge chunks of the trees that are not relevant to the query. That's why it is a very, very efficient data structures for a lot of such graphic applications. People, everybody understand how to implement the report? It's the main thing that you need to do in the homework. Excellent. Quadtree for shapes, for example, segments. Here I have triangles, A, B, small triangle, D, C, and what will be our splitting condition? There is a lot of variants. Here I'll say I'll split a quadrant if it intersects more than one triangle of the data. That's in the slides. At the homework it would be all your data is segments, horizontal segments, and your splitting condition would be if it contains if a quadrant contains more than 3 segments, I'll split it. If it contains 0 or 1 or 2 or 3 segments, I just store the segments and move on. So what is different between points and the segments or triangles? That here we see an example that one triangle, for example triangle A, you'll see the triangle A is stored in several different leaves of the tree, which is absolutely fine. Triangle A appears in several different leaves of the tree because it overlaps with quadrant 0. So quadrant 0 stores A. Similarly, it overlaps with quadrant 1, but in quadrant 1, the north east quadrant, there are more than one triangle, so we split it, and quadrant 1, has only one triangle. That's why 1, the sub quadrant, the northeast quadrant of the northeast quadrant, stores the triangle C as a leaf. Again, the policy will be only leaves stores data. And once you are keeping down the recursion, you'll see that quadrant A is stored in multiple leaves of the tree, and that's fine. And that would be our splitting policy. Okay, let's play a bit with let's try to build such a quadtree, but now let's change the location. So data would be horizontal segments. As you have in your homework, and both project and in the homework, so horizontal segments, and the splitting policy split if contains at least 4 segments. So that's the conditions that you have in the homework. Let's see how it works. So here is my region. That's the region of R of the root of the tree, and at the moment I don't have any segments in the structure. So my data structure is just a root, and I stored nothing with the root because I didn't insert any segments so far. And now I'm inserting a segment S1. So how do I tell you about the coordinates of this segment when I do it via the mouse or via an insert operation? When I do it via the mouse or via the inserted operation from the file, your program should accumulate both. You will give the command insert as a line, and then comes x1, x2, and y. x1, x2, and if the segment is horizontal, then both endpoints have the same y value, so I just tell you 1/3 number y. And let's decide about the names. The first segment that I'll insert, or when I'm asking you to report segments, it's actually not explicitly said in the homework. When I ask you to report the segments, I ask you, tell me what's the name of the segment, for example. And the name will be the first segment, S1. The second segment that I'll insert will be S2. The third will be S3, and so on. So the naming is just done automatically. So now the root stores S1 was just inserted, and obviously S1 will the root will store the segment S1. By the way, that's my S. It's scribbled S. And do I need to split the root? No, I don't need to split it because it contains one segment. So the root will store an array of at most 4, even though the 4 is not legit. I'll tell the root you can store up to 4 segments, but temporarily. Permanently, after you are done with the insertion, every node should contain at most 3. Temporarily, 4 is okay. So S1 is here. Do I need to split? No, there is only one segment. Let's now insert S2. S2 will be sit here. I still don't feel any need to split. Let's insert S3. And so S3 is stored in the root, and the root checks, do I still have only 4 segments? Only 3 segments, at most 3 segments, all fine. And now let's insert S4. So temporarily you can have 4 segments, but at this point the root realizes that there are too many children, so we are going to split the root into 4 children. And of course split the quad tree accordingly. Make sense? What triggered the split? What triggered the split was that a node realized that it stores just 4 segments, so it must be split. And again, in practice, of course, you can change these parameters. At the homework, I decided that 3 is the right number. What should I do after this split operation? The root just became internal node. It used to be a leaf, now it becomes internal node. It has children. And the root, it's not the responsibility of the root to ask who stores what. Instead, I'll go to each one of the 4 children and let it pick out of the 4 segments which segment it wants to store. So the northwest segment, northwest stores nothing, empty set, empty leaf. Right? Northeast, look at all the segments, check for each one of the segments in my region or not. If yes, then I'll store it. And remember, the same segment can be stored by 2 or more nodes. Northeast, realize that only S4 is in its region, so it starts storing S4, I'm sorry. The south, what's next? The southeast stored S3 and S1. Southwest would store S3 and S1. And similarly, the last will store S2 and S1. So sure, it kind of in one segment might be stored multiple times. That's fine. People, make sense? How to do the insert? Of course, in the case that one of these nodes contains, one of the children contains 4 segments by itself, which is quite possible, I'll have to split it again. And splitting always into 4 children. Splitting always into 4 children. Questions? That's the insert operation that you need to do in homework 1. And it's kind of answer one of that's the insert that you need to do in project 1, and I kind of answered one of the homework question in homework 1 about what should be the shape of the what happens in different cases of horizontal segments. Is this clear? And everybody understands that the same set of segments might go into children and so on, and possibly the height of the tree and the number of nodes might be quite high. For example, what should I do if I'm limiting to a budget of at most 4 segments, but I want a really I'm trying to be annoying, and I'll try to generate just with 4 segments. I'm trying to generate as many nodes as possible. How could I do it? Help. Where should I put my 4 segments if I want to generate a lot of nodes? So first limitation is that if I'll have 4 segments, one identical, one on top of each other, then of course no matter how much I split, I cannot resolve it. So let's assume that it's 4 segments each where there is no points, and the same goes for your input. There will not be any 2 segments at the same that share the point. I will not have 2 segments, one input and another one that overlap at some point. At least not deliberately, we will not have it. We will not try to do it. And you don't need to worry too much about input, about checking errors in this case. Like if we happen to give it in the input file and then by accident, then whatever your program is doing, it's fine. We will not worry about it. Okay, so assume that I don't have any point, any location of any point of a segment that is shared by 2 segments. And I will not have 2 segments that start and ends at the very same point. All these redundant conditions, we will not give them, at least not deliberately. If they happen, whatever you're answering is the same. Another point that one might ask, here let's assume that I draw it as a whole invariant, but let's assume that Q, my query region, and let's say that I have a segment that has an endpoint on the boundary. I'll assume that Q contains the point on the boundary, the query region contains a point, so a segment that has a point on the boundary is considered as intersecting Q. Q contains its own boundary, the query region contains its own boundary, so a segment that has anything to do with the boundary itself considered as it intersects the query. So if I want to report all the segments that intersect the query, I have to report ones that are just on the boundary of Q. So if you took math, then Q is a closed set, not an open set. Okay, back to my question. Q is what I have for budget for 4 segments that shares nothing with each other. How should I place them so my quadtree will have maximum number of nodes? Help. Okay, this will be one. Another one very close, another one very close, another one very close, very, very close to each other. And then how would the quadtree of this creature would look? Or how many nodes will it have? Well, a lot. Very much a lot. Because I split, because there are 4 segments, so I need to split, and then I'll split again, and then I'll split again and split again. So if I'll just draw the quadtree without the segment, you'll see that there is a lot of splitting happens as you are getting closer to the segments, and this goes recursively further and further and further until you get to the minimum age. So you might definitely end up with 2 to the age, say if age is 10, you might end up with an order of 1,000 many nodes in the quadtree. So that's, this input sucks. Okay, but that's fine. Quadtrees are still very happy to be used despite having these limitations. Okay, so let's talk a bit more about specific of the homeworks. I think that Quadtrees, we understood everything that you need for the homeworks. We'll talk more about Quadtrees more in later stages of the course. Quadtrees have lots of clever tricks going on for the Quadtrees. One of these tricks, yeah, let me show you. I'll draw it in 1D because it will be enough to understand this idea. And let's assume age equals 3 in this example. And so my range will be the point 0, 1, 2, 3, 4, 5, 6, 7. Everybody agrees? That's my range. Start at 0 and ends at 8 minus 1, making it 7. And let's assume that my data point here is P1 at 2. Here is P2, and here is P3. That's my only data points, but I drew them on the whole line. P1 is 2, P2 is 6, and P3 is 7. And I want to create a Quadtree for all these points. 1D Quadtree, but it's good to understand the 2D case. So I have the root. I have the root, and what is the range of the root? R of the root are the numbers 0, dot, 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 7. To the roots there are, so here is the root, and to the root there are 2 subtrees, because we are on 1D, so it's only 2, not 4. So what is the range of the left subtree? R of L, help. What would be the range, if the root has a range of the numbers between 0 and 7, what would be the range of the left subtree? Remember, the range has nothing to do with the data. If I split, I always split there. So, help. If I split the whole range. The whole range was 0 to 7. So when I split to the left or the right, I don't care about how the input is distributed. It's in Quadtree, as different than other data structures, you either take the decision to split, yes or no, but once you decided to split, you split in geographically the middle, so the left and the right has the same area, same dimension, no matter how many data points you have in each region. So the region of the left node will be we'll have the left node and the right node, and R of the right node. Again, split at the middle. So R of the left would be 0, dot, dot, 3. Only 4 points. And R of the right would be 4, 5, 6, and 7. Make sense? But is the font large enough? It's my, yeah, it might be that my computer again have start to play it harder. They are. They are not on D12 directly. Go to the syllabus, and in the syllabus, go to the list of lectures, and you'll find slides in the. Do it online, and I'll get back and tell me if you find them. Again, once you see the list of topics in the Google document, there is a link to the slides. Okay, so we decided that R of the left are the numbers 0 to 3, R of the right is the numbers 4, 5, 6, 7. I look at the left subtree, and maybe I'll split it, so the region of this one would be 0 and 1, region of this one would be 2 and 3, region of this one will be 4, 5, 6, 7, and so on. So one would be 6 and 7. Left subtree will be left empty. Right subtree will be left, and from 2 is 10 alone over here. So left of subtree will be 2. But let me add all the edges nevertheless. So 0 and 1, 2 and 3, 4 and 5. And remember, the numbers that I stored here, the set of data contains the point 2 and 6 and 7. And now I ask you to find the node that contains, say, the point 2. How do I find the node that contains 2? I'll go to the left subtree, then I'll go to the right subtree, go to the left subtree, and so on. Makes sense, right? It go to the left, go to the right, go to the left, then you'll end up at 2. Go to the go to 7, go to the right, go to the right, go to the right. And now I want to show you something that I find very cool. Usually we are standing, I give you a query point, and I want to ask what leaf contains my query point. You need to ask, is this going into the left subtree or to the right subtree, and I need to compare it with somehow the value in the right. But can I look at one bit of the input? Let's write 2, 3, and 7, but let's write what is 2 in binary. And let's use only 3 numbers. 2 in binary, just 3 digits, will be 0, 1, 0, I think. 2 written in binary. What is 7 written in binary? 1, 1, 1. Six will be 1, 1, 0. What is a path that leads to 7? Start from the root, go to the right, go to the right, go to the right. How do I get to 6? Root, go to the right, go to the right, go to the left. See? You look at the string, at the number as a binary representation, and you look at one particular bit of the number, and just from one particular bit, in this case the third bit, it will tell you are the numbers that you are looking for. Is this in the left subtree or is this in the right subtree? You don't need to compare this number to any values that you stored at the root. Since you always know how to store it, then that the splitting is always in the middle, then just by looking at a single bit, you know, should I go branch to the right or branch to the left when I'm searching for a number? And so on as you're going down. You'll start by checking the, in this case, the third bit, then you're moving to the second bit. Again, 1 means go to branch to the right, 0 means branch to the left. Okay. And until you're going to the third level that tells you branch to the right, branch to the left. How would you implement it if you really want to squeeze milliseconds, microseconds? How would you implement it in this comparison? How do you isolate a single bit in a number? Hacking question, programming question, not data structure. How do I know what's the value of a single bit in the number? But the quickest way. This type of operation has a name that you have probably seen. And this operation exists in C, exists in Java, exists in any programming language I'm aware of, I think. Again, I have a number x, or I have a number q, and I want to ask what is the value of the third bit of q, second bit of q. How can I do it efficiently in a single operation? Without using division, without using multiplication. Bits, yes. Shifting, you don't need to. It's bitwise end. You will take a mask. You have a mask that equals to, if you want a third bit, you will write 1, 0, 0. That will be a mask. And you're doing bitwise end. So if this is a mask, then mask bitwise end q, and asking is this number is 1 or 0. That is, if this, the mask bitwise end q, the query point, equals 1, then I'll go to the right, otherwise I'll go to the left. Not crucial, not extremely crucial, but definitely making the usage of Quadtree much faster. And of course, in 2D, you are just doing this masking both in the x and the y direction, and taking the 2 bits, the 2 answers, and it tells you, do I need to go out of the 4 pointers in Quadtree? Do I go to the first, second, third, or fourth? Okay, so it means that I never need to know exactly for a node V what is the region of V. It's enough for me to just have a delay of a second of the video. I don't need to know the region of V. It's enough for me to just know when I visit a node V, if here is my tree and I visit the node V, then I just need to know, did I go left, right, or which of the 4 children did I went on my way to V until I reached V, and then I know from this operation what is R of V. It's nice. As I said, in the homework you are allowed to store it in node V also what are the lower left, upper right corner, so you don't need to use this trick. But practically, Quadtrees are also attractive because you don't need to store any added data at nodes of the tree. Make it much faster. Okay, talking a bit about the homework, just what do I expect you from the homework. You first read, for everything is in processing, so you can visualize it. You need to know what is a age, which tells you what is this region that you're working on, which could be 2 to the age by 2 to the age, and from the region age, that's the first line in the input file, age might be much larger than 9. Age could be smaller or larger than 9. If age is smaller or equals than 9, then you're showing the whole scene fits into your screen, because your screen should only have 412 by 412 many pixels, and that's what you want to show. If age is larger and there is input outside, you still only show the parts of the input that is that's the only part of the input that you need to show to the user. If there are if age is larger, it just means that I can have input points from the file. I cannot identify them by the mouse. I cannot click on them, but at least in the input file, I might have much larger numbers. And what happens in the input file? So you insert segments either by the command input I in the file, or clicking input interactively, and you insert segments, the horizontal segments. And as segments are inserted, you don't need to worry about deletion, but you don't need to worry about the deletion. None of the operation is deletion. Had I asked for deletion as well, then sometimes you need to merge 4 children into a single node, and you can do it only if it has together they have at most 3 segments. Here in the implementation, you don't need to worry about deletion. You are for 4 segments, you'll split. Maybe you'll split further, maybe you'll split further, and so on. And then at some point, the user or the input ask for a query, and then in the query, I'll click on one point. Let's switch color. I'll click on the lower left corner. I'll click on the upper right corner. You look at the query region that these 2 corners define, and you have to report, if it's a report query, tell me all the segments that intersect this part. It's very easy if you can just check for each segment directly, does it intersect or not, but we look at your code to see that you are doing it properly. And properly would mean you are building the Quadtree, and now you implement the report function, that the report procedure that we discussed 30 minutes ago, that check for every node of the Quadtree. Hey, it intersects the query, it does not intersect the query, and if it does intersect, is it fully inside the query region, is it partially overlap, and so on. The same for stages that are listed in the report. Please implement it. That the checks until you zoom in, you boil down to only the pieces of the Quadtree that are inside the query region, and then you're checking the segments in particular, are they intersect, but only basically you are working over the same shapes that we had in the report. In the in the report over here. Okay, the same. Yeah, sorry, not here. Not here. Here. Okay. What should you do if the first point that I clicked is not smaller in x and y than the second point when I specify the query, whatever you want. Hopefully type an error message, whatever you want. We'll share with you a template that will allow you to have bottoms that to pick which mode it is, or just type a letter. We'll share with you the template. You don't have to use it. You can hard code the name of the file, but if you want to be able to pick an input file from your folder, we'll show you how to do it. Not necessarily, and this part, by the way, you are welcome to share with every other student or ChatGPT or whichever how to add the nice user interface, but that's not what this course is about. How to pick files if you want, or you can assume that we are not checking if your program is bulletproof or bad input. Your program, it's okay if your program crash or do something unpredictable on illegal input, for example, to segments that intersect or to segments that starts and end at the same point, and so on. Queries that is not well specified. As I said, the query region contains its boundary. For the operation of count, there is a report and there is a count. Count just needs to report how many endpoints of segments do I have in the query region, not how many points. And for this, you want to have for every node in the Quadtree, I will store this counter that tells me in the region of this node how many endpoints of segments do I have. And once you realized that for some root of the Quadtree it's completely inside the query region, you don't need to really visit any of the endpoints. Just take the number that is writing in the counter and add it to the overall counter. Don't go visit any of its children. Once you are sure that R of V, the region associated with V, is fully inside the query region, which, as we said, for rectangles, very easy to check. X smaller than minimum x smaller than minimum x, maximum x larger than maximum x, and so on. We ask you to animate. There is a stage of animation, and we'll give you the template. We'll show you the template in a few days that will include how to animate what happens during the search. During the search for the query, I need to, for example, here is my Quadtree. There is my Quadtree, and there are the segments that you don't see, and I specify the query. The query is a rectangle, but for these purposes, let's decide that the query is a disk, so you'll see the difference. And I need to animate what are the quadrants that you are visiting. I mean, a way for us to monitor and for you to debug that your search visits the right pieces of the tree. I ask you to animate for every quadrant that you see, make it blink for like a few hundred milliseconds or so, make it blink for a moment, and then go down. And we'll show you how to blink it in processing, how to make it highlight, having like wider widths for a second, and then go back to normal, just to indicate that we visited this quadrant. And the same will go to this quadrant, and same will go for this. Again, my experience with previous courses, students tends to like very much this, that the debugging and the processing and everything is something that you can visualize. And yeah, that think that in general the comments were that people were happier with implementing in processing in graph, where you see everything blinking in colors and visualization, rather than I type the right output. We will not be extremely careful about the output that you're doing. I don't know if we'll use any automatic parts or not, but in terms of how many white spaces you are printing and what exactly happens. Probably we don't care. What happened to my OBS? Yeah. Yeah, maybe it's a good time to stop here. Do you guys have any questions? About what is expected from the homework. So in the homework again, as the spec says, you start from the canvas that shows all or part of the region that where things are happening. You insert a segment. We'll call this segment S1, just first one, second one. So when you report it, tell me what's the name and the coordinate of each one of the segments. And as you are inserting more and more segments, either from the user or from the input file, you will build the quad tree that is split nodes. Every node of your quad tree will store an array of up to 4 segments. Store the array of up to 4 segments, maybe less than 4, but once you get 4, then it's a signal for you to split the node, and each one of your subchildren will check is this region inside me or not. So it's the children job to ask out of these 4 segments, which one of them am I going to store? And if one of these children stores all 4, then it needs to be to split. And yeah, that covers, I think, everything that I wanted to do about a Quadtrees. Any? Mm, uh, uh, no, on the homework or the you're checking what overleaf is saying. As I mentioned, always use overleaf because if I want to add data, sometimes it's changing, and if it's very crucial changing, I'll send a post to Piazza that I made some crucial changing. But if it's not crucial, if it's just editorial, then change something in overleaf. So the recommendation is always take a look at the overleaf version. And the PDF, of course, that's the overleaf. I don't recommend to print the homework once and never to use overleaf again. If somebody asks me something and I want to reward something, so the homework due date is the 6th, yeah, I mean Sunday midnight. And as usual, I'll give an extension because I always do. And but yeah, at this point, try to submit your homework. Our next topic is merge sort, and there is a question about merge sort that but you know what, this question, I'll move it to the second homework because formally, yeah, yeah, so one question will be removed from the homework about a merge sort. Yeah, and we're running out of time. And each homework has its own due date. I'll make sure that the syllabus is appropriate, but if there is a conflict, what there is on the PDF counts. Shouldn't be a conflict, but if it happens. So the homework, what day is 18? Mm-hmm. That's very. I'll wait. Okay, I'll make sure that you all have. It's a bit worrisome, but I'll make sure that you will have the nice, the correct version. If bear with me a sec. Yeah. Yeah, by the way, you notice that I'm trying to use Twitch because of its superior quality. Not always I could. So things usually have our own Piazza, our own D2L, but sometimes I'll try to keep recording also for backup on Twitch. Okay. Anyhow, I'll post on Piazza after the class to make sure that the dates are all well aligned. The quick answer: early next week is homework 1. End of the month is project 1. That's a plan at the moment. And yeah, try to be very much on time. But if you'll need a bit more extension, let me know. I don't see much point of being, different instructors have different opinion or different feels differently. Stefan Kuberov, that I have huge respect toward, I think that he's doing fantastic job, fantastic instructor, but he believes in a cup of death policies that at the day of the submission at 5 p.m. you are cutting a line and it's strong. You cannot submit any later. And I tend to be more softy. But and I'm not trying to argue that one policy is better than the other. But once again, early next week, homework 1, end of the month, project 1. Technical question about the project? Cool. Call it a day. Sorry for technical issues. I'll see you. Maybe we'll try to squeeze another. I feel much better talking to people rather than just assigning new or older files. So maybe we'll try to have another meeting this week on Thursday if I'll have time. Thanks, everybody. Bye. Okay. Thanks for sharing the time. Bye-bye.